but for real, hi! I miss you all. I hope you're excited to learn. I did try and record one other time, but I chopped my head off, and so I'm back to the drawing board here. I just want to say hello, and I miss you. I already said that, but yeah, I really mean it. I know that since we didn't have school Monday, I wasn't able to get you all a paper copy of the notes that we're going to be going over, but they are uploaded on the school website, so if you need a copy, they're there. But I also realize that not everybody has a printer available to them, so you can always just follow along on a piece of paper or computer paper, lined paper, whatever you've got. But I hope that you can get something out of this. So today we're going to start Chapter 9, Quadratic Functions and Equations. We're going to start by graphing, everybody's favorite, so I hope you're excited. If you think back to linear equations, there are how many forms of a line? Oh, by the way, we have a special guest here today. He's right there. Okay. How many forms of a line? 2. And the first one we all know in our sleep is y equals mx plus b. And what form is that called? Good. Slope intercept. Yes. What's the other form? Yeah, standard. And what's it look like? Good. Yeah. You got your ax plus by equals c, where your x and your y are on the same side of the equal sign. Yeah, so a little bit of review there for your linear equations, but today we're doing quadratic equations, and there are 3 different forms. So we're going to start with the first form today. It's called standard form. So if you've got your notes, go ahead and get those out. Follow along. I'll try and zoom it in here for you so that you can see it as we go. Buddy is thriving here at home with constant attention and fresh water. And food. Okay, his color's even coming back. Anyways, so Chapter 9 notes, they're on the school website. But again, you can just follow along. Maybe watch this video 17 times. It'll sink in eventually. All right, so quadratic equations. Here we go. A quadratic function. Okay, there we go. And if you ever need to, just pause the video and I'll zoom it in for you so you can get the words. A quadratic function is U-shaped. So we're not drawing just straight lines anymore. And it's called a parabola. And the degree of the function is 2. My 7th and 8th period, I know that we didn't really get to the point where we're talking about the degrees of a function. But the degree of a function is just its highest exponent. So the degree of this function will be 2. So we're talking about x squareds. It's quadratic. All right, so first we're going to start with the parent graph. Remember, that's just the most basic form. No fancy this and that, shifting left, right, just like x squared. What's it look like? So there's our function, y equals x squared. We've got a table here with some different x values we can plug in. So we're just going to start with, some of the basics. So -3, -2, -1, 0, 1, 2, 3. And then what are we doing to those x values? We're squaring them. So multiplying it by itself. So if we're taking -3 and squaring it, -3 times -3 is a +9. So all of your y values over here in your range are going to be positive because you're squaring your x values. So -2 squared is 4. -1 squared is 1. 0 squared, 0 times 0? 0. 1 times 1? 1. 2 times 2? 4. 3 times 3? 9. And there you go. And then if you come over here to your graph, you can plot your points. Notice that what you end up getting is U-shaped, okay, and then a couple other things that you should notice is that at the bottom of that U, this is called your vertex, okay, so it's that point at the very bottom of the U shape. The vertex is very important. That's going to be most likely the focal point of every single one of the different forms when we graph them. So starting with the vertex, and then if you notice, there's not a constant slope on the sides of the U shape. So you don't go up 1 over 1 every single time. Like if you notice, we're going up 1 over 1 and then up 3 over 1. So there's not a constant slope. The curves on the sides are a little bit different than a straight line. And I want you to get familiar with that parent graph pattern. If you look at the XY table again, when you're taking 1 and squaring it, you get 1. 2 squared is 4. 3 squared is 9. I really want you to get that stuck in your brain. 1 squared is 1. 2 squared, 4. 3 squared, 9. Because if you can remember that pattern, it will help you later on when it's not so straightforward. So tuck that in there. All right, we were asked to label the vertex and the axis of symmetry as well. So our vertex is right here at 0, 0. And then our axis of symmetry. So what you should also notice about a parabola is that it's symmetrical. You should be able to cut it in half and fold it, and it lies on top of itself. So the axis of symmetry is this line right here. What kind of a line is that? Vertical. And what's the equation of a vertical line? X equals a number. And what is that X value right there? 0. Okay, so that's the line X equals 0. That's our axis of symmetry. All right, so a couple different fun facts. Standard form. Here's your first form of a quadratic function. It is y equals ax squared plus bx plus c. Maybe you saw that on the board at the beginning of the lesson. If not, you can always rewind and get that. Okay, so 3 different parts. Here's your quadratic term, your linear term, your constant term. Okay, constant because there's no variable. It doesn't change. It remains the same. A bunch of different fun facts about your parabola. If it is in standard form, remember how I said the vertex is a really important part? Well, there's a process to find the vertex. And the first thing you have to do is find the x value of the vertex. So you've got some point that's your vertex, and to find the x value, there's a handy-dandy little formula, and it's the opposite of b over 2a. So x equals the opposite of b over 2a. Can you see that? There you go. So if we're trying to find that vertex, the opposite of b over 2a, where your b value is right there, but the opposite, so if it was positive, you would want to plug in a negative. If it was negative, you would want to plug in a positive. Over 2 times your a value, which will be your leading coefficient there. That gives you the x value of your vertex. Then you may be wondering, well, how do you find y? Well, look, y equals, and once you know what x is, plug it in and solve for y. So we'll do a couple examples like that. Your axis of symmetry. If you notice, remember it was x equals a number because it was a vertical line. So whatever the x value of your vertex is, that's going to be the same thing as your axis of symmetry. So the opposite of b over 2a, whatever that x value of your vertex is. All right, some fun facts about parabolas. Your a value is super important. It tells you a lot about your parabola before you even graph it. So you should know what it looks like before you even graph it. Your parabola will, open up if a is greater than 1. So, just kidding. Greater than 0. Okay. Greater than 0 if it's a positive number. So that leading coefficient a, if it's positive, then your parabola is opening up. But your parabola will open down if your a value is less than 0. So if it's a negative number. And so the very first thing right there, you're looking at your a value. If it's positive, your graph's opening up. If it's negative, your graph's opening down. Simple. All right, next. The parent graph parabola is what's called, bear with me here, stretched. Okay. Stop it. Yeah, okay, come. Yes. Let's try this instead. No, not today. Okay. Yes, technology. All right, let me exit out of here. Try again. P.S. Hope you're all still staying active too. I got a fun little workout for you again. Okay, here we go. Please draw. No! Why? Your parabola is? Why? Why do you do this to me? Okay. Pause.